So I just want to give some insight about complex variables. Why do you care about this subject? So really, historically, complex analysis and complex variables sort of came from calculus and basically trying to um, understand the real numbers in a more general approach. So obviously, we know that the real numbers are a subset of the complex numbers. So, what's interesting is that, um, really why people care about it, at least in a non theoretical spot, is the fact that we can start to understand how to evaluate some integrals, how to look at series in more general approaches, trying to think about when some series converge, their radius of convergence. There's sort of a lot to say about uh, looking at doing certain integrals, especially for Fourier transformations. And there's some things called conformal mappings. So really, what's interesting about complex analysis is this idea of uh, what you call residues and residue theory. So when you're looking at complex functions, for example, uh, it sort of counts your perspective on it. But a lot of times, what you can do is you can look at a real value problem on the complex plane, because if we think about the real numbers here and the complex numbers up here, well, the real numbers are all on this line, right? So even though we might be doing stuff in the so even though we might be doing stuff with the real numbers, we're really doing it on the complex plane because R is a subset of the complex numbers. So there's sort of a lot of interesting results here. Specifically, doing a lot of uh, you know basically indefinite integrals, Fourier transformations. Uh, there's sort of other things. There's an important one called convolution theorem, which is related to basically Fourier transformations. And there's also this idea of conformal mapping, which is very important for this area called PDEs, partial differential equations, and other things. Um, so really, just in addition to really understanding uh, mathematics in a more general place, complex variables gives you a lot of tools to solve um, a lot of problems related to improper integrals. I said indefinite before. I meant to say improper. Um, and also, it also lets you see the relationships between trigonometric functions and uh, basically, uh, there's a few relations, really complex numbers and the relation to trig functions, how imaginary exponential functions are related to uh, imaginary trigonometric functions. There's things to say about derivatives of complex functions, how those work. So overall, really, people that really care about this stuff are electrical engineers. Another set of people are PDE people. Totally butchered electric. That's fine. So, and there's a lot to say actually for numerical analysis here too. And so there's a lot of applications of complex variables in both a theoretical sense and an applied sense. So that will be my video right now, but I will start adding more videos with complex variables very soon.